Hey everyone, welcome to yet another video on the Walker's Facade. Last time in our videos we discussed about spandrel panel and shadow boxes. If you haven't seen that video, have a look. I am sure you might get something to learn about spandrel panels. Today we'll talk about something that I'm sure you must have read in shop drawings or in project specifications or maybe in consultant comments. They usually don't forget to mention that. You must have seen these rust stains on facades, especially on cladding panels, even white powdery stuff on joints between cladding or on the screw joints on the cladding panels. Why I'm saying cladding? Because that is the first thing that this might be visible from the outside. What it is? Rust, corrosion. There are multiple ways how corrosion happens, but in this video we'll be talking about something that is a little bit more technical: bimetallic corrosion or galvanic corrosion. What is bimetallic corrosion, how it happens, why it happens, how it can be prevented, and all these things we'll discuss in this video, so stick on. Bimetallic corrosion happens when two dissimilar metals are in contact with each other. When two dissimilar metals are in contact with each other and there is a presence of moisture between them, this basically forms a battery. How? Well, every metal has its own potential. When two dissimilar metals are touching each other, the potential difference between these two and the moisture in between, which acts as an electrolyte, forms an electrical connection. And this electrical connection helps the electrons to flow from one metal to the other metal. Say metal A and metal B are touching each other, and metal A is, say, aluminium, and metal B is, say, stainless steel, and there happens to be moisture in between them due to humidity or rainwater or whatever. So here aluminium has a slightly positive charge and stainless steel has a slightly negative charge because of the potential difference. We'll discuss about how this potential difference is checked and determined, but for now, for the understanding of it, let us consider this. What happens in the presence of moisture is that the electrical circuit is completed and electrons start flowing from the anode to cathode, and in this process these ions of aluminium starts breaking up and forming aluminum oxide, which is the white powdery stuff that you see around these joints. That is corrosion. So now here in this example, aluminium starts corroding. Why aluminium starts corroding? Why not the stainless steel? We'll see further in this video. But this is what happens, and this is basically what bimetallic corrosion is. So in this system, we have an anode, a cathode, and moisture, an electrolyte. So these three factors are what makes the battery work. If we remove one of these factors, we stop the battery and bimetallic corrosion is prevented. That's the basic idea of it. Let's dive deeper. As I said, every metal has its own potential, and based on the potential of each metal, some material engineers and scientists have come up with a chart which is called galvanic series. This is the galvanic series. In this galvanic series, you will see the metals being listed on a chart on a series based on their potential. Higher the metal on this list is more active, and lower the metal, that is more noble. So farther the two different metals are apart from each other, stronger the potential difference and stronger the possibility of bimetallic corrosion. As I said, to form this battery, electrolyte is very important, and moisture is the worst enemy of bimetallic corrosion, or say best friend of bimetallic corrosion. The bimetallic corrosion happens mostly when there is moisture content in between the contact point. Moisture could come from anything such as humidity in the air, condensation, rainwater seepage, or even sea blast, especially when the environment is, say, salty in the coastal areas or polluted in some of industrial areas. That is where the moisture could accelerate bimetallic corrosion. Because of that pollution, the water becomes more conductive of electricity, and that adds to the damage. It's important in facade because we use various different metals in facade, right? Mullions made of aluminium to inserts made of mild steel, and then bolts and screws made of stainless steel, brackets made of galvanizing is zinc, right? Galvanized steel, and then it's fixed onto concrete with stainless steel bolts or GI bolts. So there are already, we have stainless steel, we have galvanizing, that is zinc, we have mild steel, we have aluminium, different alloys, different metals, all combining together to form the facade. And this, we were talking about just the curtain wall. There is cladding. In cladding, we use stainless steel cladding, zinc cladding, aluminium cladding, even copper cladding, copper in the sense brass. Brass is an alloy of copper. Then there are screws, bolts, anchors, rivets, which are made of different materials, mostly stainless steel and sometimes galvanized, right? Then there are brackets, framing behind, cladding installation. We have framing made of mild steel behind, onto which the cladding is fixed with aluminium bracket or MS bracket, which is hot dip galvanized, which brings zinc into the mixture. Then there is stainless steel bolts. So in facade, there are various points where we use different metals together. Even there is a possibility of rainwater fall off, which is wild for me as well. So what happens is, copper is very noble material. So in the galvanic series, copper comes up very low, and aluminium is an active material. Aluminium goes up very high. So say there is a copper panel on the roof. For whatever requirement, architect must have thought copper would look good on the top, and then he might have given aluminium cladding, say, on a canopy. So what happens is, when rain falls on copper, this rain droplets might break out small particles of copper, and then this rain falls onto aluminium cladding. And where this rain falls, the rain droplets brings copper, and this copper along with water touching aluminium forms the battery, and thus the corrosion. Here corrosion begins, and you can see, well, this is a rare case, but if these conditions are met, you will see white aluminum oxide forming where the water falls. This is another case of bimetallic corrosion that may happen in facades. So basically it can pop up anywhere. It can pop up on brackets, on cladding, on screws, on framing, on even the cladding panels itself. Now, bimetallic corrosion can pop up anywhere, but is it preventable? Yes, of course it is preventable. You are not seeing rust everywhere, right? So of course it is preventable. Now, how we can prevent bimetallic corrosion? Smart material selection. That is the first and foremost thing that a designer must think of when he's designing facades. The closer the material is on the chart, the lesser the potential difference, and lesser or less stronger is the bimetallic corrosion or the possibility of bimetallic corrosion. So using material that is closer to each other on the galvanic series is the foremost important factor when designing facades. Insulating the dissimilar material, or say bimetallic separator. This is probably the word that you have read in the drawings or project specifications. So what is a bimetallic separator? Well, it's a piece of non-conducting material. When you have, let me sketch. So when you have two dissimilar metals, say this is metal A and this is metal B, you add a layer of bimetallic separator, a non-conducting material. What is a non-conducting material? Well, basically plastic or rubber or EPDM or neoprene or nylon, anything that is non-conductive, you can add between two different metals, and the bimetallic corrosion is prevented. When there is no contact, there is no bimetallic corrosion. You can even add washers between the screws. Say this is one metal, say aluminium, and then this is stainless steel screws. You can add a neoprene washer here, which reduces the contact patch between stainless steel and aluminium, and thus prevent bimetallic corrosion. This is such an easy fix, but this is best when it is thought of in the design. Protective coating and treatments also work. protective coating like powder coating on aluminum or stainless steel, and anodizing aluminum, or painting steel members that goes inside or is in contact with some other metal. But the problem with protective coating is that the protective coating might damage during the installation. There might be scratches or dents, or the paint might just chip off in some areas, and then when you fix it on site, these protective coating might have chipped off and bring the two different metals in contact with each other, and thus failing the preventive measure. Drainage and waterproofing, that is also one factor. In this example where we discussed about stainless steel screws on aluminum, we can have a waterproofing membrane on top of it covering the whole assembly. What this waterproofing membrane does is prevents water to enter the system. If there is no water, if there is no moisture, the battery is broken and bimetallic corrosion is prevented. Yet there are possibilities of condensation since there is air inside, this air might condense onto these joints and seep in, causing corrosion, and those must be thought of during the design process and tried to prevent it. So in such cases where condensation is a possibility and water moisture might get in, there should be a provision for drainage. Whatever the subsystem is, there should be, say, a hole for such condensation to pass through and prevent buildup of moisture or water in the system. Area ratio is another factor. In the same example, say this is the aluminum panel and this is the stainless steel screw. So since this aluminum panel is large and stainless steel screws is small, the rate of corrosion will be very small, and this rate of corrosion will eat up aluminum but at a very slow rate. Say we flip the situation and we make this the anode. What happens here is now the rate of corrosion might be similar, but the material is very small, the anode is very small, and the corrosion might just eat up the main part and break the joint. So this is what we call the ratio of metal in the joint. If we are forced to make a joint of two dissimilar metals and we cannot provide any other preventive measures, we at least need to make sure that the ratio is small, the anode is larger than the cathode. Then comes environmental considerations. So we have to consider the salt or pollutants in water. In a coastal area, it is obvious that the air, the moisture, the humidity contains salt in it. So when the water condenses onto these metal components, say in winter when this morning dew happens, or even in summer, say the air is very humid and the insides are air conditioned, that might cause air to condense onto the metal surfaces and form water droplets. Rain is a big factor. Facade is obviously an external part of the building, right? So it is facing the weather. So especially in the industrial areas where there are pollutants in the air, when rain falls down, that rain brings down the pollutants in the air and falls onto these metal surfaces with those pollutants, causing or making a good conducting electrolyte between the two metal components, making the battery even stronger and forcing bimetallic corrosion or enhancing bimetallic corrosion. Quality control. Quality control in installation and in fabrication is very important. Even if the designer has given the best possible solutions in his design or in his specifications, if during fabrication or during installation, if the quality control is not good, if the material is not handled properly, if say the washers that were supposed to be installed are missed out or not installed, say the coating is getting damaged or waterproofing is having punctures which are not properly sealed, all these factors add to the formation of battery, right? So that is enough to bring up bimetallic corrosion in the system. So that's why quality control is very important, and also is maintenance. The maintenance should happen on the scheduled time, and the maintenance should be deep and thorough to ensure that there are nothing that is missed out in the inspections. And if you find something that is corroding, or even if you find something that was missed out during the installation or quality control inspections, you must raise the point and get it rectified to prevent bimetallic corrosion in the longer term of facade. So when we summarize the whole thing, the most important factors that you should consider in preventing bimetallic corrosion, the first thing is material compatibility. As I said, galvanic series need to be referred to, and the metals that you're using must be ensured to be not too far apart on the galvanic series. Quality control, as I said, no matter whatever procedure that you have set on paper on your system, if the quality control is not strong, if you are not monitoring the installation and fabrication of material, then all the preventive measures that you have decided in your design might fail. Design early, not on site. So even these plastic washers, the nylon washers that I talked about, to be placed between the fasteners and material, these plastic washers can be very cheap if bought in large quantity during the procurement stage, and for that it has to be ensured to be mentioned in the design itself. Sometimes these minor details are missed out in the design stage and it is found out on site, and when it is found out on site, it becomes very difficult to procure the material at a good price, and you will have to buy it locally. You might not get a good quality product, and all these things, especially the drainage solutions and waterproofing solutions. These solutions have to be thought of at the design stage. On site, these solutions are very, how would I say, jugadu. Jugadu is a word in Hindi which means not perfect or imperfect solutions. Just to prevent or just to avoid the problem on site, people just come up with random solutions to just get over with. Environmental considerations, as I said, salty environment, city environment, polluted environments, these need to be ensured. These need to be considered when designing facade. Small details, devil is in the details. Clips, screws, rivets, anchors, washers, these things are where you miss out in design, and these are very important. So when you're designing facade, you have to ensure that you have this eagle eye to look for minor details. Multiple line of defense, that is an important factor. Redundancy of protection is a good idea. What I'm saying is, in the example that I just gave, this stainless steel screw being cathode and the aluminum cladding panel being anode, here we are giving, say, let me use another color, okay? Here we are using a washer, that is one preventive measure. We have used material that is not too far apart from each other on the galvanic series, that is another preventive measure. We can, say, provide waterproofing membrane on top of it, that is a third preventive measure. So what happens is, if something fails, if waterproofing membrane fails, there is washer that can prevent corrosion. If you miss out the washer, there is waterproofing membrane that could prevent corrosion. And if both of these fails, the metals used are not too far apart from each other, and the rate of corrosion will be slower. Well, now it remains on the quality control. The quality control should catch up that something is missed out or something is damaged and should be rectified. Documentation and guidance is another important factor. Whatever design that we are doing or the designer has made need to be well documented in project specifications and in drawings. It is the best solution to mention a simple sentence saying that bimetallic separator has to be provided wherever dissimilar metals are found to be touching each other. Simple as that. This does not prevent everything, but at least this gives the idea to the contractor or to the installer that you are serious about bimetallic corrosion, and they should do whatever they can to prevent such. Similarly, guidelines for maintenance. Now, it's only the designer and the contractor and the installer who knows what they have designed, how they have installed. Once you have given the project, once you have handed over the project to the client, they don't know about how these designs have been done. So there should be a proper guideline set up for maintenance, and this guideline should clearly show how the design is made. So that is one of the reasons why I earlier said that design early. So design early means you have to Also provide a solution for maintenance. The panel should be removable, the bolts and screws should be accessible and such, right? So if you make sure that these factors are considered in design, in fabrication, in installation, in quality control, and then in maintenance, there is a very low possibility of having a trouble with bimetallic corrosion. So there you have it, a crash course on bimetallic corrosion. I hope you learned something. I hope you learned more than just reading bimetallic separator in the project specification and in the drawings. Let me know of your thoughts and experiences. If you have experienced such problems on site, if you have seen two dissimilar metals being in contact with each other without any preventive measure that we just discussed about, let me know. You can put your comments in. I will make sure that I reply to the comments and we can have a discussion on the comment section. Even people who are much more experienced than me, maybe I have made some mistakes in this explanation. Let me know if I have done so. Maybe we can correct it in the comment section, and maybe we can have it recorded in the next video. Also, ask any questions that you have regarding facades, not just about bimetallic corrosion, any other matters in facade that you are finding it difficult to understand, and who knows, maybe the next video is based on your comment. So thank you for tuning in, and I hope to see you again on the next video. Keep learning, keep building. Thank you.